So we're going to take a look at question 6 from the 2018 Junior Cert Higher Level paper. So it's an interesting question. There's a lot of topics mixed in the one question. So this could be a question we could say is about patterns, but equally we could say this is a question about functions. And it's a question that was fairly generously marked, like there was 10 marks for the first number of parts of the question. So we're told that a sheet is folded in half a number of times. H of x is equal to 2 to the power of x. So we have this exponential function to represent the number of layers after x folds. So if we input values for x for the number of folds, the outputs will be the number of layers in that sheet of paper then. So we want to fill in the table to show the number of layers after each of the first 6 folds. So it's a good idea to fill out a table to represent folds 4, 5 and 6. So if I sub in an x value of 4, this is 2 to the power of 4 and the number of layers is 16. If I sub in 5, the number of layers is going to be 2 to the power of 5, which is 32. And then if I sub in 6, the number of layers will be 2 to the power of 6, which is 64. And we just fill those into our table. Now what we can see is clearly the number of layers is doubling each time we fold the piece of paper. And again, this is an exponential pattern, and that's actually one of the questions that's coming up later on. So 10 marks for that A part. The B part of the question then asks us to list the elements of the domain and the range. So remember, the domain is the inputs, so in this case that was the number of folds, and the range is the outputs, and in this case it's the number of layers. So the domain are the number of folds, 1, 2, 3, 4, 5 and 6. And then the range is the outputs, the number of layers, 2, 4, 8, 16, 32 and 64. And again, there was 10 marks for this. The C part of the question asked us to work out the least number of folds that we would need to have more than 500 layers. So at Leaving Cert Higher Level, we can use what's called logs to solve a problem like this. But for Junior Cert, we literally just had to write out the number of layers. So we have 2, 4, 8, 16, 32 and 64. These were the number of layers for each of 1, 2, 3, 4, 5, 6 folds. And so we can see that we would get to 512 layers after 7, 8, 9 folds. So we'll need to fold at least 9 times to have more than 500 layers. The D part then says work out the number of layers after 12 folds, and then we have to give an answer in the form a times 10 to the n. So again, we have a function that we were given at the start of the question where if we input number of folds, the output will be the number of layers. So we're going to input a value of 12 for 12 folds, so x is equal to 12. We get 2 to the power of 12, and then our calculator gives us the number 4096. Now this is quite a small number to put in scientific notation. Generally, scientific notation is for really large numbers to make them more manageable. But the question does ask us to write this in the form a times 10 to the power of n. And then for scientific notations, we get various conditions. So a is a real number between 1 and 10, first of all. So what real number will I start with? Well, I have a leading digit here of 4. So that's going to be my number between 1 and 10, followed by a decimal point and whatever numbers come after that. So 4.096. And then for the second part, to figure out what the n is for the times 10 to the power of n, we just count the number of digits after the first 4. So 1, 2, 3. And so this is going to be 10 to the power of 3. And we were told that n had to be a natural number and 3 is a natural number. So part D, the question then says, explain what the following statement means in terms of folds and layers. So they say that H14 is greater than 10,000. And all they're saying here is that if the number of folds is 14, then the number of layers will be greater than 10,000. And so one way we should follow this up is by actually proving that with the maths. So in English, the statement we could make is that when we have 14 folds, we have over 10,000 layers. And mathematically, just to show that, we're going to sub 14 into our function. So h of 14 is 2 to the power of 14, which is 16,384. And so what we're saying is that when we have 14 folds, we have 16,384 layers, and 16,384 is bigger than 10,000, as was made in the original statement. So part F of the question is quite easy, as we've already made reference to the fact that this was an exponential function or an exponential pattern a number of times. We can see that the number of layers is doubling each time, and so it has a common ratio or a multiple each time of 2. So we go 2, 4, 8, 16, 32, 64, and so on, and it will continue to double, which is an exponential pattern. Parts G and H of the question were a little bit more difficult. What we were told in part G was that after a certain number of folds there are K layers. And then it says how many layers will there be after 3 more folds? Well, we know that every time we fold the paper, we double the amount of layers. So if we had K layers after a certain amount of folds, well then if we fold it another time we'll have 2 times that. And if we fold it again we'll have 2 times that. And if we fold it again, we'll have 2 times that. 2 times 2 times 2 is 8, and multiplied by the k, we have 8k. So if we originally had k layers and we folded it 1, 2, 3 more times, we'd now have 8k layers. Part H says after a certain number of folds, there are 2 to the power of p layers. So we were told in the last question there was k layers. Now we're given it in terms of the number 2 and a power, so we have 2 to the power of p layers, and it says how many layers will there be after 3 more folds. So we do know that after 3 more folds there will be times 2 times 2 times 2 layers. And how do we know that? Well, the pattern continues to double each time we fold it, so 2 to the power of p times 2 times 2 times 2 means we're going to fold it 3 more times. Now we're going to use the rule of indices here to tidy this up. So we have 2 to the power of p, and then multiplied by, we have 2 by 2 by 2, which is 2 cubed. And one of the rules of indices tells us that if we have the same base number, so for example 2 to the power of p, and then we multiply that by another number which has the same base, so 2 to the power of q, the rule is that we keep the base 2 and we add the powers, and p and q would be p plus q. And to give an easier example that would have numbers, if we had 2 to the power of 3 multiplied by 2 to the power of 4, that would be 2 to the power of 3 plus 4 is 7. So coming back to our own example here, how would we tidy this up and join these together? Well, 2 to the power of p times 2 to the power of 3 is 2 to the power of p plus 3. Again, we just add the powers. And they say, give your answer in the form 2 to the power of m, where m, the power, which is what we have here, is in terms of p, and that power is in terms of p. And so the answer to the question is 2 to the power of p plus 3.